Okay. So as a quick review, we just finished the sign rules for adding and subtracting. I'll put this back up here for a second, and then you guys are going to tell me what you did with your answers. So what we saw was, if both numbers have the same sign, then we said that we would add the absolute value of the numbers and keep the same sign. And we had worked through some examples like that. We'll run into more of these in a minute. If they have different signs, then we subtract the absolute value of the numbers and take the sign of the number that has the larger absolute value. Okay? So now you're working on these order of operations questions. And the first one is this one on G, which is 2 plus 7. Hold on a second. I'm going to do that. 2 plus 7 plus a negative 3. So tell me, using order, first of all, do you remember what's the little thing you remember for order of operations? PEMDAS. Please excuse my dear Aunt Sally. Okay. And what we're going to do is follow order of operations here. So where did you start? The parentheses. And notice we have a parentheses around negative 3, and then these are brackets around the 7 plus negative 3. The brackets are just a different type of parentheses to help you understand where one set of parentheses starts and the other one stops. So we call the brackets the outer parentheses. That inner parentheses around negative 3, I can't do anything with just a plain negative 3, but I can work on what's in the brackets, which is 7 plus negative 3. So you tell me, using the rules we just covered, what would 7 plus negative 3 equal?
4.
And it's positive 4, isn't it? And if I add 2 plus 4, that gives me
6.
Okay. As I walked around the room, I saw most everybody had 6. That looks good. Terrell people, you good too? All right. Now, if you look at H, where do you start on this one with order of operations?
Parentheses.
And that negative 2 plus 5 is going to be how much?
3.
Okay, so notice I just copied down the 6 and the plus, and when I get to this bracket, I'm going to take the negative 2 plus 5, which gives me a positive 3. Then that's going to have 7 added to it, which is how much? 10. So 6 plus 10 is?
16.
All right. So if I were to ask you real quickly, how many of you got both of these right? Let me see, thumbs up. Okay, perfect. Okay. So now, let's move down the page a little bit. And we'll talk about subtraction, because so far, everything we've looked at has been adding, whether we had both positive, both negative, or one of each. But sometimes we're going to see subtraction signs with some negatives involved. There's a short little add-on to the rule we already know that lets you take care of subtraction easily. And that is simply this. Subtraction is the same as, and I'm going to put this in quotes, adding the opposite. Now, here's what I mean by that. The opposite means the opposite sign. So if a number was positive and I am going to have a subtraction sign in front of it, I'm going to change it to a plus, and I change the positive sign to a negative. I'm going to take the opposite sign. So in other words, you need to be sure you make 2 marks if you're changing something to adding the opposite. I can't just change a subtraction to a plus and not make another mark. That would only be 1 mark. I'm going to have to make 2. And as we go through this, I think you can see. So here's sort of the idea. If you were using the number line, and this is probably the only one I'm going to use a number line on, just so you can see. If we tried to do 6 plus negative 2, I'm going to put a scale on here, And let's say that's 0, 2, 4, and here's 6. 1, 2, 3, 4, 5, 6. So this would tell me if I started at 6, a little circle there, and I want to add -2 to it, which way do you go if you're adding a negative? Left, because negative would go to the left, a positive would go to the right. So if I back up 2 units, 1, 2, that would tell me my answer is +4, correct? Now, if I have 6 minus 2, don't I end up in the same place? 6 minus 2. So what I'm saying is subtraction can be turned into adding the opposite. That's the same thing as 6 plus a -2. I changed the subtraction to an addition, and then I made what was after the subtraction sign the opposite sign. So it was a +2 after the subtraction. Now I make it a -2. And it works, and that means I already know the rule for that, because if I'm adding and the signs are different, subtract the numbers, and take the sign of the larger number. Now, on one like 6 minus 2, I know you don't have to do that. You're going to know the answer. Where we run into trouble is typically on something like this, a -4 minus 3. If we already have something negative and we're trying to subtract from it, sometimes we get confused. So here's what I want you to see. If I were to add the opposite, this would be the same thing as -4. What would I write next if I want to change that to adding the opposite? Plus -3. The shortcut to that, when I say make 2 marks, and I don't know if I can do this with this clunky stylus, but that would be if I change the minus into a plus and then stick another little minus in front of the 3. I've made a vertical line to make the plus and then a little negative to go with it. So for any real numbers, A and B, if I want to subtract B from A, that's going to be the same thing as A plus a -B. Okay? So in other words, for A minus B, you want to add the opposite of B to A. That's our rule. So that's just going to be a little add-on that you put at the bottom of the rule we already have for adding signed numbers. We can quickly change subtraction to adding the opposite, and then we can use the rules we already know. Okay, let's see if you guys can tell me what the answer would be to 6 minus 10. What do you think? First of all, tell me how you could rewrite it as adding the opposite. It would be 6 what? Plus a -10. Very good. And then if we use those sign rules, what would our answer be? -4, because the signs are different. So we subtract the numbers, take the sign of the larger number for our answer. Okay. I want you guys to do -2 minus 4, and then you're going to tell me what you get in just a second. You got it? So answer this for me first. Is your answer positive or is it negative? I hope everybody says negative. That's the other thing, is sometimes you get a little mixed up between rules for multiplying and rules for adding. So you want to make sure you keep it straight. If I'm adding or subtracting, then my rules tell me if the signs are the same, then after I add the numbers, I keep the same sign. If the signs are different, after I subtract the numbers, then I take the sign of the larger number in my answer. So what did you get for a -2 plus a -4? I'm sorry, yeah, plus a -4. That's how much? -6. Very good. Okay, let's look at H. You've got -8 minus -12. That's a lot of minus signs there. This is where adding the opposite, I think, is probably the most helpful, because notice I have a subtraction sign after -8, and then I have a negative sign. Here's your 2 marks, plus a positive. Okay, I made 2 marks, and now it's a -8 plus a +12. How much is that? So -8 plus +12 gives you what? Yeah, we've had a couple of differences here in answers being called out, but I do subtract the numbers. I know the number's going to be 4, but since my answer takes the sign of the larger number and 12 is now positive, that's a +4. Okay, are we good with this? Carol, you good?
Yeah.
All right, awesome. Okay, so let me clear this off. And oops, didn't want to do that. Okay, let's pull this up just a little bit. And let's try a little more order of operations with these signs. Okay, so here's my suggestion. I would take care of, first of all, as you go through PEMDAS, take care of whatever's in parentheses. But if something in parentheses has a subtraction sign, you might want to change it to adding the opposite before you start. Otherwise, we're going to take care of what's in parentheses first, and then when we get to any addition or subtraction, that's when we might want to take care of the rest of changing subtraction to adding the opposite. So let's do I together, and then I'll let you guys do J. So tell me where you start on I. The 4 plus 6. So I copy everything else down just like it appears here until I get to that parentheses. And 4 plus 6 is what? 10. You don't have to put it in a parentheses. I'm going to, just so you remember that's where it came from. We did that parentheses first. Now we do what? The bracket. Very good. We did the inner parentheses. Now we go to the outer parentheses. And I have -3 minus 10. That's subtraction. So if I change it to adding the opposite, that means I've got -3 plus -10. Well, how much is that? What's -3 plus -10? Say it again. Okay, do y'all agree with Lisa? She said -13. Very good. And now what do I need to do? I've got, yeah, the 2 minus -13. Remember, if you've got minus a negative, you can change it to adding the opposite, which means it turns into plus a positive. This actually equals what? 2 plus 13 is 15. So I had to keep up with the signs until I got to the end, but it all cleaned up to give me 2 positives I was adding at the end. Now, I want you guys to go ahead and try J for me. And when you have it, if you'll just give me a thumbs up so I know that you're done, and we'll be able to discuss our answers. Okay. Okay. All right. We're getting close over here. I've seen Keon give me a thumbs up. Anybody else done in Terrell? Okay, looks like we're there. Good deal. So I'm curious, your final answer that you got when you clean this up, was it positive or was it negative? Everybody say.
Negative.
Okay, I think I'm hearing negative unanimously. That's good. Is it a single digit number or a 2-digit number?
Single.
Single is what I'm hearing. There's a little bit of silence from some areas though too. On the count of 3, I want you to tell me what number you think it is. 1, 2, 3.
-7.
Okay, so I think about 3 or 4 of you said something. Most of you said -7, but not everybody. So let's work through this and we'll figure out what the right answer should be. Tell me where we would start. Okay, in the inner parentheses, the 5 minus 7. Now, question, did you change it to adding the opposite? Because if you did, that means it would be 5 plus a -7. Ooh, that looks really sloppy, sorry. So if I'm adding 5 plus a -7, what is that going to give me? Oops, move that over a little bit. So here, -2 from somebody. Are y'all in agreement on that? Because the signs are different. That means subtract the 2 numbers and my answer will take the sign of the larger number. So that gives me a -2 plus 3 inside my bracket. Now, what do you get when you add a -2 plus 3? Is it a positive one or a negative one? It's a positive one, right? Because my answer takes the sign of the larger absolute value. 3 is bigger than 2 and 3 was positive. So I have a +1 minus 8. Now, that's subtraction. If I change it to adding the opposite, what is a +1 plus a -8? -7. Okay. So give me a signal now, since we've kind of rolled these subtraction rules with sign numbers into order of operations. Are we still here? Are we kind of here? Or are we saying, okay, I'm really struggling? Give me, and this is an individual thing, so just give me a quick signal so I know. And be honest with yourself. Okay, so here's the thing. If you're kind of here, fortunately I didn't see anybody do this. If you're kind of here, that may mean when we get to the homework, you may need to have your rule sheet out and look at what you wrote down for the rules on several of these until you get to where that's kind of stuck in your head. You may want to ask for some help. And so if that's the case, then you can, like I said, we can continue to do this by video or we can do it in person. And those of you on the Terrell campus, you've got some resources to go to if you need to. All right, so here are a few reminders. Be careful as you look at problems. Watch for subtraction signs versus negative signs. So for example, if you look at how this is typed here, typing it oftentimes does look the same. Sometimes the negative sign will be a little smaller and raised up a little higher, but you've got to be careful. Some calculators will not let you type a subtraction sign to mean a negative, and it'll give you an error if you do that. So watch out for that and be sure if you've got a plus or minus button on your calculator that you use that when you need a negative number versus trying to do a subtraction sign. Also, sometimes we run into things that need to be translated. So just be careful that you watch out for some of these issues if something comes to you kind of in the form of a word problem. What does the word difference mean? Anybody know? It's the answer to a subtraction problem. So this is telling me that the answer to the subtraction problem is what I'm looking for between a -5 and a -12. So if I want to translate that and write down what it looks like just using numbers and symbols, what would I write first? The -5, and then I would put minus, and then, oops, that looks very sloppy, minus, and then I would put the -12 afterward, right? Okay, so -5 minus -12, and then I could clean it up and solve it. These are the ones that are a little bit sneaky, okay? Look at this. It says -2 subtracted from the sum of -4 and 4. So in addition to seeing something's going to be subtracted from, I also see the word sum. Now, what does the word sum mean? The answer when you add. So think about this. This is an order of operations kind of deal. If I'm going to have -2 subtracted from something, don't I need to know what that something is to start this problem? Yeah, so when you see the word subtracted from, that's telling you it's subtraction, but it's written in backwards order. So I don't put down the -2 first. If I'm going to subtract something from something else, I got to know what the something else is. So since it's the sum of -4 and 4, you'd want to put that in parentheses, -4 plus 4, and then I can subtract the -2 from it. Make sense? Okay, so some of those vocabulary, we probably won't have as much of that in here as what you would see in a regular algebra class, but it's possible we could run into just a little, so that's why we're reviewing it. You're going to work the parentheses first, but think about it this way. If I need to take -2 and subtract it from something, okay, if I wrote this in the other order, if I solve this out now, okay, yeah, it's going to make a difference when you subtract, kind of like 8 minus 6 is not the same thing as 6 minus 8. So that's why we've got to make sure that if you see subtracted from, what comes after subtracted from needs to be written down first, okay? And then same thing here, look at that, 7 less than -2. Now, I think we might have discussed this illustration the other day, but let's do it again just to be sure. If I knew that I had, let's say I went to you and Sarah, you said, I said, I might need to borrow some money from you, Sarah. How much money do you have? And let's say she said, well, I have $20. And if I said, gosh, I have $5 less than you, then I have how much? 15. And that's something you just ought to, you know that because you're used to working with it in money. Think about it the same way here. If you've got 7 less than -2, I have $15 because if she had 20 and I have $5 less than 20, it wasn't 5 minus 20, it was 20 minus 5. So the same thing here. Less than is telling me subtraction, but it's backwards order. So what would you have to write down first? The -2, and then you can subtract the 7 from it. Okay? All right, so quick review on that. And then we're going to go ahead and kind of skip the last example here that kind of goes through how you would determine what the temperature would be or the high temperature, because I don't think you're going to see that. But it is time to now talk about rules when you multiply and divide with signed numbers. So let me clear this. I'm going to pull this up. And here's one thing we need to make sure we remember. You should know what happens anytime I multiply something times 0. I'm going to get 0. So if I'm trying to write equivalent equations, I can't multiply 3 by 0 because that just basically turns everything into 0. Can I divide by 0? The answer is no, I can't divide by 0. We're going to talk about that in just a little bit in more detail in case that's one of those rules you sort of have trouble remembering. So talk to me then about what do you think happens if you multiply numbers that have the same sign? So positive times a positive is a what? A positive. What's a negative times a negative? It is positive. Now, here's why. Okay? Our rule is going to be this. If we're multiplying or dividing, we're still going to look at same sign versus different signs. Okay? So if the signs are the same, either both positive or both negative, then the answer will always be positive. Okay? If we are dividing, what's a negative divided by a negative? it's still a positive. So it doesn't matter if I multiply or I divide. If the signs are the same, then I am going to get a positive. Multiplying or dividing. That's a different rule from the adding and subtracting. That's why we've got to be sure we keep these straight. So multiplying or dividing, if the signs are the same, you're going to get a positive. What do you think happens if the signs are different? One's positive and one's negative. The answer will be negative. So if I'm multiplying and the signs are different, the answer is negative. If I'm dividing and the signs are different, the answer is negative. Okay. Now, we talked about with fractions last class that if I had a fraction divided by a fraction, what do I do? Remember, if we had, say, 1/4, and I asked you to divide that by 3/8. Leave, change, flip. Yeah, if I'm adding or subtracting, I need a common denominator. But if I am multiplying, I look for things that I can reduce down, common factors. If I'm dividing, I have one little extra step first. I have to leave, change, flip, and that would turn this into 1/4 times what? Instead of 3/8, it's 8/3. And then I can solve my problem because I've turned it into a multiplication problem. So that's why we've got to make sure we remember with anytime there are fractions involved that we're going to use this. And the only difference now is some of those fractions may have negative signs, where we didn't look at any negative signs last class. But I do want to remind you why division by 0 can't happen. It is undefined. Okay? It's undefined. It can't happen. And that's because, and I'm going to write this out so it makes it a little easier to see. 6 divided by 2. We talked about the fact that a fraction simply means it's a division problem. So instead of saying 6 divided by 2 written that way, I could write it this way. And if you remember back, probably elementary school, maybe around 3rd, 4th grade, you first learned how to do long division. Then 6 divided by 2 equals 3. And what did your tell you to do check to be sure your answer was right? We're supposed to take this 3 and do what? Multiply it times 2 to make sure it equaled the numerator, right? You take your answer times the denominator and make sure it equaled, because you learned how to multiply before you did your division. That was a quick way to check, because that had to be true if you had done the division correctly. Now think about this. If I have 6 and I divide it by 0, a lot of times people will say, oh, that's 0. But stop and think for a minute. 6 divided by 0 is equal to something. What number would I multiply times 0? And the answer is 6. What happens if I multiply anything times 0? It would turn into 0, but that's not a 0 on top, that's a 6 on top. So if I have any number divided by 0, that is undefined, because 0 times nothing. There is no number I can multiply it by to get 6. Okay, that won't work. Make sense? All right, now if the 0 was on top and I had 0/6, what would that equal? I heard it. Was that Dana? Good job. 0. Oh, no, it's Sarah.
Yeah.
My hearing, sorry, I need to get my hearing checked. I can't tell where sounds come from anymore. So that is equal to 0, because 0 times 6 does equal 0. So if 0 is on top in a fraction, it equals 0. But if 0 is on bottom in a fraction, then it is undefined or impossible. Okay, so far so good? All right, one more thing I want to remind you about. This notation right here. We have a fraction, and it's showing you there are 3 different places you can put your negative sign, and they're all correct. Okay, let's put phones away unless you're using the phone to actually remote in. I think most of you, maybe Dana's using her phone. The rest of you look like you may be on computers. And so what you have here is either a negative in the numerator You could put the negative in the denominator, or you could put the negative in front of the whole fraction. Here's the key. If my fraction is supposed to be negative, how many negative signs are there going to be? How many are here? There's one here. How many is in this fraction? One. How many is in this fraction? One. It's telling you, you can decide where you want to put it. You can assign it to the top, you can assign it to the bottom, or you can just put it in front of the whole fraction. But use only one if the fraction is supposed to be negative. Because what happens if I put a negative on top and a negative on bottom? Because we said a negative divided by a negative gives you a positive because those signs were the same. Okay, so far so good? Thumbs up? All right, good job. All right, so let me clear this. Let's go to the next page. And we have several now that will involve multiplying or dividing with signs, and we also have some more order of operations to practice. So let's just do a couple of these together, and then I'm going to give you a few to do on your own. What do you think is going to be the sign when we multiply a negative 5 times a negative 6? Positive, because the signs are the same. And so 5 times 6 is 30. Good job. Okay, what would a negative 8 divided by 2 give me? A positive or a negative? A negative, and the 8 divided by 2 is 4. And if I double check, it's negative 4 times 2 equal to a negative 8. Good job. Okay, let's do this one. 1/4 divided by a negative 2/3. What do I need to do first? Leave, change, flip. Good job. So if I write it as 1/4 times, what happens when I flip negative 2/3? I get, yeah, and again, it doesn't matter if you keep the negative with the 2. If you want to put the negative on top with the 3, or you just want to stick a negative in front, now that's going to turn into what for an answer? Yeah, and I can either write the negative on top, on bottom, or in front, so I can make sure that there's one negative sign and the fraction is 3/8. Okay, when you have more than one number being multiplied together, all you have to do is, as far as getting the sign for the answer, is count up the number of negative signs. Since if the signs are the same, it gives me a positive. That means anytime I have an even number of signs. So if there were a bunch of numbers here and there's more than 2 that are negative, all I do is count up how many negatives there are. If it's an even number of negative signs, the answer will be positive. If it's an odd number, the answer will be negative, okay? So what's going to be the sign of this answer? What do you think? Negative 4 times positive 3 times negative 6. How many negative signs do you see? 2. Is that an even number? So the sign of the answer is positive. And this is going to be positive what number? So 4 times 3 is 12, and 12 times 6 is 72. Double check that in your calculator and make sure that you would get a positive 72. Okay? Now, I want you guys, and by the way, the only thing that's different on number 5, there are decimals there, but if you're using your calculator, that's not a problem, correct? And before you would go to your calculator, can you tell me if you already know what the sign of the answer needs to be? That's going to be a positive. So I want you to do 7, and I want you to do 8, and let's see if you guys can get the right answer. I'm going to pause recording for just a second. All right, so I'm curious on number 7. I want you guys to hold up fingers for me to tell me how many digits are in your answer, either 1, 2, or 3. Okay, I see Keon's answer. Good, good. Okay, looks like most everybody's telling me 3. And was your answer positive or negative? Positive. That sounds great. So on the count of 3, let's hear if you all say the same number. 1, 2, 3.
168.
168. Excellent. Now let's look at why. When we looked at 7, what was the first thing you did? Using, very good. We had to multiply the -4 times the -5. So I'm going to come over here, and I have the -8 bracket, -1 minus, and then in the parentheses, I'm going to put what I got when I multiplied -4 times -5. And you guys tell me it's what number?
20.
It's actually a positive 20, isn't it? Yeah, and then there is that subtraction sign in front of it. So now, if I go to the outer parentheses, a -1 minus 20 is the same thing as -1 plus a -20, correct? Which is how much? A -21. And when you multiply a negative times a negative, you get a positive, and 8 times 21 is 168. Okay. Are you, give me a quick signal on that one, because there were a lot of negative signs to keep up with. Were we here, here, or here? All right. And so for some of you, you may feel a little uncomfortable if you're not using your calculator, but if you're using your calculator, you feel pretty good. How many of you are kind of in that boat? All right, I see a few of these. Yeah, if you give me my calculator. I'm not going to take your calculators away from you, but I do want you to be confident that you know the sign rules so that you can tell if you type something in wrong in the calculator that can't be the right answer. Okay, now if you look at the next one, number 8, can you tell me, did you get a fraction or did you get a whole number answer? I'm hearing lots of whole numbers in Athens. What about Terrell?
Whole number.
Whole number. Was it positive or negative? Positive. Can you actually show me the answer using the fingers between two hands? All right, so on the count of 3, hold up the right number of fingers. All right, I see Keon. And I've got several people here with the right answer. In case you got stuck, it should have been what number? 2. Now let's look at why. If you were to start with this fraction, where do you want to start? Numerator. And that means I'm going to use order of operations in the numerator. So what was the first part to do? 6 times -4. I've got multiplying, subtraction, and multiplying. So I do all the multiplying first. 6 times -4 is a -24. And then I had a subtraction sign. And then there's 2 times 3, which is 6. So you should have gotten, yes, ma'am.
I'm sorry, I have a question.
Yeah.
Okay, so when you do the -6, am I supposed to add like an extra parentheses and put -6, or can I just do that?
Okay.
That is what.
Okay, so got a question here. Could y'all hear her and Terrell? She was asking whether we needed a parentheses around the 6, right? Or if we could write it this way. That is your call. If you want to, like if you cleaned up what's inside a parentheses, or if you multiply 2 things together and you want to put it in a parentheses to remind you this is what I got when I multiplied, the parentheses is optional, except if you have something like where you're going to have a minus sign and what's in the parentheses, we're going to look at this in a second, is like this, where you can't combine it. Okay, but if I get a single number, then it's up to me whether I put it in a parentheses or I just write that number down. So that's a good question. But I need to figure out what a -24 minus 6 would be. I'm going to change my subtraction to adding the opposite. And a -24 plus a -6 is how much? That would be a -30, correct? Oh, we've got some debate here. Some say positive, some say negative. What do you guys think? You got to think a little louder than that because I can't hear. Okay, is that going to be a positive or a -30? Negative, because remember, with our addition rules, if the signs are the same, you add the numbers and keep the same sign. So that's a -30. Okay. Over. Now, tell me what you did first in the denominator. That's right. I do the parentheses. So if I have 2 minus 7, that's actually the same as 2 plus a negative 7. And how much is 2 plus a negative 7? That's a negative 5, isn't it? Because the signs are different. Subtract the numbers, take the sign of the larger number, and 3 times negative 5 is negative 15. Do you see now why the answer is going to be positive 2? Because we have a negative divided by a negative to get a positive. 30 divided by 15 gives me 2. So the answer to this one is positive 2. Okay, if you need some practice, you will get it when you do the homework, which is going to be review 1.1b, and we'll have more of these in there. Now, as far as what comes next, again, we probably won't see this so much in this course, but in case, you either have to go into algebra, or if you take Math 1325, I think I mentioned to you guys, that's really business calculus, and you do need to know your algebra in that course. So that's why, in case somebody's going to need it coming out of this course, we're going to cover a little bit of some of the algebra just to make sure that you've got some basics down. And so what we're going to have is substituting in values for variables. Now, I say we're not really going to have that much of it in here. Honestly, we kind of do. We're going to have some formulas, and they're going to, because they're formulas, you're going to see letters, and then we're going to have to know how to substitute in for whatever that letter stands for, because we'll be talking about interest rate and principal and time and things like that. So on this one, if we were to evaluate this, 2 times x minus 7 times, and in parentheses we have y plus 1, my suggestion to you is this: wherever you see a letter, you want to put an open parentheses and then go back and plug in the number that they're telling you to use. So where x is, it tells me x equals negative 4. So I'm going to put a negative 4 there. And my y is supposed to equal 3. And if I do that, and on this one I would say, yes, definitely put those open parentheses where the letters were, and then plug those numbers in. Because if you don't, then you may think that you're going to, like if we didn't put a parentheses here between the 2 and where the x belongs, we might look at that and think we were doing 2 minus 4, that it's subtraction, but it's not, it's multiplying. So the parentheses will help keep you straight on operations as well. So talk to me about where you would start here. The only thing I can do in a parentheses is this right here, the 3 plus 1, which is how much? Yeah, 3 plus 1 is 4. So I'm going to have everything else stay the same, but when I get to where that parentheses was, I'm going to put the 4 inside the parentheses. And now I've got 2 times negative 4 minus 7 times 4. So I've got multiplying and subtraction. What should I do next? Multiply. So how much is 2 times negative 4? That's a negative 8. And then I have minus, how much is 7 times 4? And how much would a negative 8 minus 28 be? Y'all agree? She said negative 36. You think that's right? Okay, I see Keon nodding his head. And that's because subtraction is the same thing as adding the opposite. And a negative plus a negative means add the numbers, keep the same sign. And that's a negative 36. Make sense? Okay. Now, let me show you this one on 10. I've got 3x squared minus 4y squared, and they're telling me what numbers to put in for x and y. So I'm going to do the 3, put a parenthesis and a square, minus 4, a parenthesis and a square. And where the x was, I'll put in negative 2, and where the y is, I'll put a negative 3. Now, here's where you got to be really, really careful. If I am depending on my calculator and I don't type this in correctly, I'm going to get the wrong answer because it's going to give me the wrong sign. So if you guys who are working with your calculators, if you'll go ahead and do that, I want you to see what you come up with, and we're going to see if we all are getting the right answer here before I explain to you what you need to be sure to do. Okay? So you take 3 times, and then in parentheses, I've got the -2 squared minus 4, and in parentheses, I've got the -3 squared. When you've got an answer, just kind of raise your hand so I know you're done. Okay, so I'm curious, those of you who have finished, are you getting an answer that's positive or negative? Say negative? Anybody else there? So you say negative, you say no. You got positive? Okay, anybody in Terrell, did y'all all get the same sign, or what did you get, positive or negative? John, what'd you get?
Negative.
Okay, you got negative. What about you, James?
Negative.
You got negative. All right. So here's what I want to warn you about. If you used your calculator and you type in a -2 and then you hit the x squared button, what does your calculator say that's equal to? It'll say -4 because the calculator is going to follow order of operations. And if there's no parentheses there, the only thing being squared is the 2. And after you square the 2, then it multiplies it times that negative sign that's in front and gives you a -2. On the other hand, if you open a parentheses and you type -2 and you close it and then hit the x squared button, that's telling the calculator, I need you to multiply -2 times -2, that the number -2 is what's getting squared, and a negative times a negative gives you a what? A positive. So you're going to have a sign mistake if you're supposed to use exponents and you've got a negative base and you don't use parentheses in your calculator. All right? Be very, very aware of that. And if you're not using the calculator, you can still do this. You just have to remember that and that's why I said put those parentheses, an open parentheses where your letter was, because that's going to help you keep it straight. What's actually being squared is the number -2. And if I multiply negative times a negative, that gives me a positive. So 3 times +4 is a +12. That's that part of the cleanup. Minus, and then the same thing on the last part. If I square -3, that's -3 times -3, which is how much? Negative times a negative gives me a positive. So I would have -4 times +9. And 4 times 9 is 36. So you end up with 12 minus 36, which is -24. Make sense? Head's going this way. Where are we getting stuck? Which part doesn't make sense to you guys? Do you understand the difference between this and that? They are not the same thing. An exponent is only attached to what's right in front of it. So in this case, the only thing getting squared is the 2, and then you put a negative sign in front of what you get after you square 2. And that's why this would be -4. But on this one, the exponent is attached to the parentheses. So it means the number that's in the parentheses is what's getting squared. And a negative times a negative gives me a positive. You get different signs depending on which way you work this. And the parentheses makes a difference here. okay? So anytime you're substituting in for a variable, they give you a letter and then you're going to have to plug in a number for it, I would always put an open parentheses where that letter was so that when you plug in the number, you won't make a sign mistake. Yeah.
I think that has a subtraction sign.
Like this line right here.
So -4 is correct. I always think that that's going to be negative, so that I think -4 times 3.
Okay, that's an order of operations problem because would I multiply before I would do the exponent? Okay, so here, in case you couldn't hear her in Terrell, here's what she was saying. It's when she looks at this part right here, and let me see if it's possible. Let me see if I can change color, but I don't see easily how to do that. So, oh, maybe, yeah, let's do it this way. So here's what she's saying, is when she gets right here, when she looks at that, she sees the -4 times the -3, and she's wanting to make that a positive. But what I'm saying is that's an order of operations mistake because, think PEMDAS, what do you have to do before you multiply? Parentheses and exponents. And I've got to take care of this exponent before I can worry about the multiplying. So that's where you're going to have to be careful because you're right. It's very tempting to want to go through and just kind of work with all those signs at first. But keep in mind, if you know that's a struggle for you, keep thinking PEMDAS, okay? And write it down so you'll take care of those in the right order. All right, anything else going on that you guys want to ask about? Okay, so if I were to ask you, how many of you remember the distributive property? How many hands do I see? I've got 1, 2, 3 here. Some of you probably, you may think, I'm not sure what she's talking about. And when I start to explain it, you're going to go, oh yeah, I remember that now. Distributive property is just the principle that if I have something that is in front of a parentheses, whether it's a number or whether it's just a negative sign, because remember, if it's just a negative sign, it's the same thing as the number -1, that it has to get distributed or multiplied times everything in the parentheses. Now, as long as everything's just numbers, like we've been working up here in 7 and in 8, we can always clean up what's in the parentheses. You realize class starts at 8?
We do.
Yeah, we have, this is 2 periods. You need to be here at 8. Okay, I didn't say anything Monday because I just figured you were running late, but yeah, it's both periods. Okay?
So the HA
Is part of our class. We actually, yeah, we run from 8 to 10:40. Okay, all right, so distributive property means what's in front of the parentheses, whether it's just a number or it's just a negative sign, has to be distributed or multiplied times everything that's in there. Kind of, the idea is this, if you guys are my class, and you are, and I came in with a giant bag of candy and I said, I'm going to distribute candy today, and I start passing it out, and I skip 2 of you, is that going to be a problem? I think it probably would. You might not say anything right then, but it's definitely not going to be okay with you. And so that's why if something's in front of the parentheses, you got to distribute it times everything in the parentheses. So that's what this is explaining here. You got to multiply the A times the first term, which is B, write that down, plus whatever that sign is, bring it over, and then multiply that A times the second term, which was C. If there's a subtraction sign between them, you're going to keep the subtraction sign. And it doesn't matter if what is outside the parentheses actually comes in front of it or comes at the end, it still has to distribute times everything in the parentheses. So let's see if we could use, yes, whatever's outside the parentheses, if there's not a plus sign or a minus sign after it, between it and the parentheses, that means it's got to multiply times everything in the parentheses. So let's multiply everything in this parentheses times 2. And what would we get? 2p plus 10 plus 6 cubed. That's it. It's just it gives us the ability to get rid of parentheses, because sometimes when we do that, then we end up with terms we might be able to combine. We'd have some like terms. Okay, what about number 2? With a negative 4 in front of the parentheses, if I distribute through, that gives me what? Negative 4y, and then what? Okay, watch out, because if I put the plus sign down, then I'm multiplying negative 4 times 3x, which is negative 12x. So I can either write it as negative 4 plus negative 12x, or I can think of this as a negative 4 times a positive 3x and just write it as minus. Because remember, plus and negative is the same thing as subtraction. So you can either write it this way, or you could write it as negative 4y minus 12x. You just need to be sure there's only one minus sign there, but there needs to be a minus sign, okay? Now, look at number 3. What do we do with that? Distribute the negative. Think of it as a negative 1. So if I multiply negative 1 times 3k, that's what? Negative 3k. And then what's negative 1 times negative 5? Yeah, you can, if you wanted to make that minus 5, think of it as adding the opposite. Basically, you're assigning that negative sign to the 5. So when I multiply the negative 1 times the negative 5, I get the positive 5. If I have just a minus sign right in front of a parentheses, all it's going to do is change the sign of everything in the parentheses to the opposite. That's what happens when you multiply by a negative 1. So if I were to ask you to signal me, how many of you say, I'm good, I get this, signs are not going to be a problem for me here, I know what the distributive property is supposed to do. Okay, we won't have a lot of that in this course, but you would have a fair amount of it in the next course. We'll probably see a little bit of it here, but the main thing is going to be doing the evaluating that occurs above here. Let's do 4, and then we'll move on to something else. So if I've got a subtraction sign in front of the negative 5y plus 8, what's that going to turn into? Okay, the negative 1 times the negative 5y is positive 5y. What's going to come after that? Okay, I've got 2 options on how I write it. If I put the plus sign down, then the negative 1 times 8 is a negative 8. You could write it that way, or you could write it as 5y minus 8, right? Either way is okay. All right, you guys ready to look at something else? Yes, sir. We can. Do you want to?
I was just going to, if you want to.
Yeah, let's go ahead and do 5 just for a little practice with fractions. Yeah. Now, let me just remind you, you may find it helpful instead of, like when there's fractions involved, I don't know that I'd want to multiply this in my head. So what I would do is show, I'm going to take the negative 4/3, and I'm going to multiply that times the first term in the parentheses, which is 12y. I'm going to put my plus sign down, and then I'm going to take the negative 4/3 and multiply that times the last one in the parentheses, which is 15z. Okay, now, to clean this up, I've got a fraction times something that doesn't look like a fraction. Could I make that look like a fraction? Yeah, if I want to put that over 1, then I have a 3 on bottom and a 12 on top. Is it possible to reduce that down? Yeah, 3 goes into 12 how many times? 4 times. And if I multiply this negative 4 times 4y, that's going to be how much? Negative 16y. Are we good with that? Plus, now here, I could do the same thing. I could put that 15z over 1, and will 3 go into 15 evenly? 5 times. So that cancels out there. This becomes a 5. And what would we get if we multiply that together? I'm going to have a negative 20z. And you can either write it as minus 20z or you can write it as plus a negative 20z. So even though it had a fraction in it, it actually cleaned up to be whole numbers after we multiplied. Does that make sense? Okay, if we need some more help with this, then we're going to have an opportunity to do that at the end of class. All right, I'm going to move this thing up a little bit. And when we talk about simplifying expressions, that simply means if I've got variables, so if I see like x's or y's, that's typically algebra, we're going to have formulas. So we may see R for rate, or T for time, or P for principal or starting amount. And we may have some things that we need to work with. If that's the case, then we need to make sure we understand if I have other terms that have those letters in them that I'm trying to add or subtract together, I can only combine things that are like terms, which means they have to have exactly the same variable raised to exactly the same power. In other words, an x is not able to be combined with an x squared because the x has an exponent of 1, but the x squared would have an exponent of 2. So not only do the bases or the letter have to match, but the exponent that's on it has to be the same too. So that's the part about having like terms to put them together. Otherwise, I'm going to keep them separated, like 3x squared plus 4x. That's as simple as it is. I can't combine it to be one term. The other thing you need to know is that the number that goes in front of that variable is called a coefficient. Have you heard that word before? And that's just the number being multiplied times whatever that variable is. So if you don't see a number in front of a variable, what does that mean your coefficient is? Like this, it's just x. It's just 1. I don't have to write the 1 because it's understood. Just like I wouldn't put an exponent of 1 because it's understood. Any other number for an exponent or coefficient has to be written down. So if we were to look at this, what would be the coefficient on A? What's our coefficient in 15Q? The number part, 15. Okay, what's our coefficient on B? The -2. So if there's a negative sign, it's included with the number as being part of the coefficient. It's just if there's an exponent there, the only thing that the exponent is attached to is what's right in front of it. All right, and on D, what would be your coefficient there? Oh, that's C, is -18. You're right. What about on D? -1. Very good. Okay, so we would include that sign with it. Now, if I were to ask you about like terms, can you tell me, is A, are these like terms or not? Yes, they are. So I'm going to circle it because they're like terms. What about on B? Are those like terms? No. So if I don't circle it, it means that they're unlike. I should say that instead of dislike. What about on C? Are those like terms? We got one yes and one no here in Athens. What do you guys say in Terrell? C, are those like terms or not?
No.
No, and the reason is why?
The exponents.
Good. They tried to trick you there. You have to pay attention. On the first term, the x has an exponent of 2. In the second one, the x has an exponent of 4. So they switched the exponents. That means they are unlike. How about on D? Are they like or unlike?
Unlike.
They're like. Because there, they do match up. Remember, the coefficients don't matter, but the variables and the exponents have to match exactly. How about E? So let me ask you a question. What's happening with the 13 and the K and the T? Are those things being added, subtracted, multiplied? What are you doing?
Multiplied.
They're all being multiplied. So here's the question I have for you. Is 2 times 3 the same thing as 3 times 2?
Yeah.
So do you think the order matters if you're multiplying? So are these like or are they unlike?
They're like.
They are like. It doesn't matter that they put the k first in one and they put the t first in the other. Since it's still the same variables with the same exponent, they're like. Okay? All right. Now, when you simplify, it simply means if they are like terms, you are just going to add the coefficients and the exponents and variable part stays exactly the same. So if I had a 4k plus a 7k, what would that equal if I combine those? 11k. They're like terms, so all I have to do is add up the coefficients. Think of it this way. I don't know what k is. I have one teacher that I work with, she explains it to people, I mean, maybe it's a dog. So you got 4 dogs plus 7 dogs. How many dogs do you have? 11. And that's why you're going to keep that variable just like it is. It doesn't change. You're just adding up how many of them are there. Now, what about 4r minus r? Are those like? And that's going to be 3r because what's that coefficient in front of this r? 1. We don't see it. It's actually minus 1. So 4 plus a negative 1 gives me 3. What about on C? 8p plus 8p squared. They're not like, are they? I can't do anything with it. That's as simple as it gets. Okay? And then we'll do, just to get a little practice with parentheses, let's try doing these last two. I want you guys to work on those, and then we're going to see if we get this simplified to be the same thing. Help you work through this one. Now, what did you decide you needed to do first on I? Okay, we do have a parenthesis, but here's the question you have to ask yourself. I have 1 plus z in the parentheses. Are those like terms?
No.
No. So I can't add those together because I don't know what z is. Think of it like if I had 1 plus pickle. It's not I have 1 pickle plus another pickle. I just have 1 plus a pickle. Those don't combine to be one thing. They stay, like if I have a dollar bill and a pickle, it stays a dollar bill and a pickle. So that 1 plus z, I can't put it together. So then I don't see any exponents, but do you see some place where there would be some multiplication? Do you notice that what's in front of that parentheses? It's not a plus sign. It's a what? It's a minus sign, which is the same thing as a -1. Okay? I've got to multiply everything in that parentheses by -1. That's the first thing I'll do to get rid of the parentheses. So I still have 7z minus 2. Now, if I multiply a -1 times a +1, what does that turn into? A -1, right? And then I multiply a -1 times a positive z. What does that turn into? Plus a -z, right? That's distributing by multiplying everything inside that parentheses by the -1. It changed both the signs. So I now have a -1 plus a -z. Now let's look at what we have. We have 7z minus 2 minus 1 plus a -z. So what am I going to put together? I got to look for like terms. So what I have for like terms would be a z term here and a z term here. What is this 7z plus a -z going to be? Say one more time.
6z.
I hear a 6z. Do you guys and Terrell agree? Good job. Okay, so 6z. And I've already combined those. The only parts I haven't combined would be this. I have a -2 plus a -1, or -2 minus 1. But I'm going to take that minus into plus a negative. So what's -2 plus -1?
-3.
-3. So did you get 6z plus -3 or 6z minus 3? Either shake your head yes or shake your head no. So I kind of know. Does that help? Does that make more sense now? Okay, let's look then at J. And we're going to kind of work through this one together too. And then we'll go practice some of these. So if I look at J, tell me where you think you need to start. All right, very good, because we've got the same issue. What's inside the parentheses, they're not like terms, so I can't clean that up to make it one term, but I do see what's right in front of the parentheses is going to be this -3, because remember, that subtraction is the same thing as adding the opposite. It's like I'm multiplying everything in the parentheses by a -3. So I'm going to have 9K. If you want to, change that -6 to plus a -6. I can do that. Plus, now I multiply -3 times 2. What does that give me? What's -3 times 2? -6 plus, and now I'm multiplying a -3 times a -5K. What's that? Well, hang on, it's a negative times a negative, because remember that -5K is the same thing as adding the opposite. That's like putting the negative with the 5K. So negative times a negative gives me a positive, and 3 times 5 is 15. So 15K. We good? Okay, so what happens when you put like terms together here? I put this 5K and the 9K together. Remember, any sign that's in front of a number is going to stay with the number. So 9K plus 15K is?
24K.
24K. And then what happens when I put these two guys together?
Be 24K minus 12.
24K, and it'll either be minus 12 or plus a -12. I will accept either way. Usually we do clean up double signs in our final answer, and we would write it as 24K minus 12. But if you write 24K plus -12, I'm happy with that. So I think let's stop here for today. Okay. Pause recording.